Hello everyone and welcome to Pentagon. Today's problem is a bit different than usual. It's a logic problem. And this problem is courtesy of the logic book The Lady or the Tiger and Other Logic Puzzles by American mathematician Raymond Smullyan. Now, you have been transported to the magical land of Narnia, and due to your sheer ecstasy at arriving at Narnia, you decide to rob the Queen. Now, of course, you're captured and taken prisoner, but the Queen is a bit eccentric in her punishments. Every prisoner of Narnia must go through a trial in which there are two doors in front of them. Each door leads to a room that could contain either a beautiful lady or a ferocious tiger, and the prisoner must choose only one door to open. If the prisoner opens a door with a lady behind it, the prisoner is set free, possibly marries the lady, and goes on to live a happy and prosperous life. However, if the prisoner opens a door with a tiger behind it, the prisoner is instantly eaten by the tiger. However, the Queen won't let your decision be based entirely on chance. Each door will have a sign in front of it to help the prisoner logically deduce if the door has a lady behind it or a tiger. Now bear in mind it is possible that both rooms contain ladies or both rooms contain tigers. Now at your trial, you are standing in front of the two doors, and the sign on the first door says, "It makes no difference which room you pick." The sign on the second door says, "There is a lady in the other room." The Queen, who is also there, tells you two very important bits of information. Firstly, if a lady is in the first room, the sign on the first door is true, but if there is a tiger in that room, then the sign is false. However, the opposite is true for the second room. If a lady is in the second room, the sign on the second door is false, but if there's a tiger in that room, the sign is true. Using these pieces of information and the signs, can you save your life and find the room with the lady? Pause the video here if you'd like to try and solve this yourself. Alright, before we start to solve the problem, we need to learn a bit of terminology of logic. Firstly, conditionals. Conditionals are statements in which a hypothesis, denoted by P, implies a conclusion, denoted by Q. And this is read as, if P, then Q. Warning though, just because P implies Q does not mean that Q implies P, so we can't always switch the hypothesis and the conclusion. Here's an example of a conditional. If today is Christmas, then we're in December. Here the hypothesis is today is Christmas, and the conclusion is we're in December. And today's Christmas implies that we're in December. This is a true statement. However, this is not always true if we flip the hypothesis and conclusion. It's not always true if we say, if we are in December, then today is Christmas. But now let's look at biconditionals. A biconditional is a conditional in which P implies Q and Q implies P. So in other words, with biconditionals, you can switch the hypothesis and conclusion. In mathematics, we can show this by saying P and Q are equivalent using a double arrow, or we can say Q if and only if P. Now, why am I saying this? Well, if we look at what the Queen told us, the two givens, these two pieces of information happen to be biconditionals. So we can rewrite these statements in biconditional form, and this will be very helpful to us. So let's do that. Let's start with the first given. We can rewrite this as the first sign is true if and only if a lady is in the first room. Before, what we had was, if a lady is in the first room, the sign on the first door is true. But now when we rewrite it in biconditional form, it's easier to see that we can also say, if this first sign is true, then a lady is in the first room. We can also say, if the sign on the first door is false, then a tiger is in the room. Likewise, we can write the second given as follows. The second sign is false if and only if a lady is in the second room. So let's use this to solve the problem. So here are the signs and here are our givens. Now, in our problem, there are two cases we have to consider, and both of those involve the first sign. Let's start with the first case, in which sign 1 is true. Now, if sign 1 is true, using the first given, we can say that a lady is in room 1. Now, let's look at what sign 1 says. It says, it makes no difference which room you pick. This means your fate will be the same regardless of which room you choose, which also means that either both rooms contain ladies or both rooms contain tigers. And since we know that there's a lady in room 1, therefore there must also be a lady in room 2. And if there's a lady in room 2, using the second given, we can say that sign 2 is false. Now sign 2 says there is a lady in the other room. Well, we just said this is false, which means there has to be a tiger in room 1. However, now we've reached a contradiction. We've already established that there is a lady in room 1 and not a tiger. So this makes no sense, and therefore we can say that case 1 is wrong. Sign 1 cannot be true, which means we must move on to the second and only valid case, in which sign 1 is false. Now, if sign 1 is false, by the first given, that must mean a tiger is in room 1. Now, sign 2 says there is a lady in the other room. Well, since we've established that there is a tiger in the first room, this must mean that sign 2 is false. And if sign 2 is false, by the second given, we can say that there is a lady in room 2. Here we don't actually reach a contradiction. Since sign 1 is false and it says it makes no difference which room you pick, well, it must make a difference which room we pick. So if there's a tiger in room 1, there must be a lady in room 2. So you confidently choose the second door, and everyone wishes you the best of luck as you walk out of the prison with Helen of Troy. Thank you all for watching this video. If you liked it, please consider subscribing to our channel. Thank you all, and I will see you in the next video.